Hi everyone, I am Bhagyalakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the case study in the topic of Laplace transforms. There is some practical applications of Laplace transforms only we are going to discuss. So very few concepts we can discuss now. It is based on the real world applications also we can discuss. The first one is the introduction of Laplace transforms. So, Laplace transform basically having three concepts. In mathematical tool, frequency domain, system behavior. In mathematical tool means here we are transforming time variant into time functions into S domain. That is frequency domain. We are changing like that. And then the frequency domain here, the complex analysis, the complex functions are simplified here. And then the third one is system behavior. It is easy to understand to calculate the sums problem statements. So here basically the time domain functions is converted into frequency domain. So in this frequency domain converted means it based on the differential equations converted into algebraic equations. So if it is algebraic equation, then easily we can calculate the calculation. We can get the analysis easily. So for that concepts only we are basically doing in Laplace transforms. So next we can see the core concepts of this way. Let's explain more.
Now we are going to see the core concept of Laplace transform. There are mainly two core concepts. One is frequency and another one is time. That is we say as a S domain, that is frequency. So first time domain. There are two factors in time domain. That is differential equations and complex convolution. And for frequency domain also that is two factors. One is algebraic equation and one more is simple multiplication. So the core concept of Laplace transform is it will convert the differential equation into algebraic equation and complex convolution into simple multiplication. This Laplace concept plays a major role in solving the problems.
So next one by one case studies we can discuss. The first one is signal processing application. Explain about this.
In this case, a signal processing application, there are three. Filtering signals, noise reduction, and modulation and demodulation. First is filtering signals. They decide and digital filters efficiency. Noise reduction. It removes unwanted sounds and frequencies, and then model and demodulation. Analyze communication signals. At last, in signal processing, Laplace transforms aid in design filters. They simplify analysis of modulation scheme. There are engineering mostly using them for effective noise reduction to avoid the noise and signal reconception. This applies to audio, image, and video, etc. So in this, we are seeing about the control systems of IT infrastructure. First, system modeling. So we create the mathematical models of IT system, and after that, we are controlling controller design that which develops for the system stability. So only after that, it performs the optimization. It ensures the IT systems run efficiently. So the Laplace transforms are vital in design controlling systems, and they help to predict and manage the systems accordingly. So in this case study 3, we are going to see about the circuit analysis for hardware design. So there is some hardware designs, and we need this circuit analysis. In this Laplace transforms, which helps to analyze this. So first is component interaction. So it helps to analyze the voltage and current responses, and then frequency responses. So it helps to analyze the different frequencies. So the time frequencies will not be the same every time. So if how the circuits are different, it helps. Then after that, stability and analysis. So it ensures a reliable hardware operation. In hardware design, the Laplace transforms simplify the complex circuit analysis. They are used to determine the circuit stability and responses. Next, in this case, solving differential equations in network analysis, there are four. First one is traffic flow, model data, calculate movement in network. Second one is congestion control. It designs algorithm to prevent network overload. Third one is security protocols. It analyzes and optimizes secure communication. And fourth one is lattice prediction. It estimates data transmission relation. It helps to model data flow and predict network performance. This aids in designing efficient frequency routing protocols and congestion control mechanisms.
Next is benefits of using Laplace transform. We are going to see how Laplace transform is beneficial in our day-to-day life. First is simplified analysis. So in simplified analysis, transfers complex problems into simpler one. And the second is efficient design. Efficient design means it aids in system and circuit design. Third is performance prediction. It will help us to predict how the performance is going to function. And the fourth is enhanced stability. It ensures a reliable system operation.
Yeah, very good. So finally, we can discuss about the challenges and limitations in Laplace transforms. So what are the main challenge we are having here means, here it is applicable only for the linear equations. It is not for the non-linear systems we can't apply. So it is very difficult to apply that. The next one is initial conditions is very important. So based on the initial condition, accurate initial conditions is given means we get the final solution easily. And then and another one thing is inverse transform complex. Inverse transform we can use effectively. So here it is a complicated one. So complex problems we can all the problems we can convert into inverse transform, and then become it is a very complicated one. So these three basic concepts we are facing in Laplace transforms. So finally, we can get a conclusion. So based on these three, avoiding these three concepts, otherwise the Laplace transforms is very effective in day-to-day life. So we can using this tool, we can reduce the noise reduction, and using many field we can use.